Hello everyone, welcome to my channel. This is Karuna, teaching the course Computer Architecture and Organization. Third unit contain the following topics. Register transfers. In this topic, we have discussed how the data transfer takes place between the registers, and also we have seen how the processor performs arithmetic and logic operations, and also we have concentrated on how processor fetch the instruction code as well as word from memory, and also we have seen the execution of complete instruction. Okay. So, to coordinate all these actions, control signals are generated by the control unit. Okay. So, in this video we will concentrate on hardwired control. Later classes we will discuss about the organization of microprogram. Introduction. To execute instruction, processor must have some means of generating control signals in proper sequence. Different computer organizers using different techniques to solve this problem. So, there are two ways to implement the generation of control signals. Those are hardwired control and microprogrammed control. In this video, we will concentrate on hardwired control. Let us see the organization of control unit. Here, this is the control unit circuit, which is used to generate control signals to coordinate all the activities of processor. This block diagram consists clock generator, control step counter, decoder encoder, external inputs, condition codes, instruction register. Okay. So, the generation of control signals depends on the information provided by the instruction register, control step counter, external inputs and conditional codes. Here external inputs are coming from other devices, for example interrupts. We will discuss about interrupts in later classes. Okay, let us see one by one. Let us divide this decoder and encoder circuit separately. See, here clock generator, control step counter having step decoder, instruction register having instruction decoder. Okay. So, let us see how the control signals are generated by the provided information from instruction register, clock generator, external inputs and conditional codes. Here step decoder, clock generator generates the clock pulses. Those pulses are incremented with the help of control step counter and provides any one of the clock cycle. Here clock cycles are T1, T2 to Tn. Okay. So, this step decoder generate clock cycle which is corresponding to the instruction provided in instruction register. Okay. So, here clock cycles are incremented by the help of control step counter. Okay. Now, here instruction register used to store the instruction. Okay. Program nothing but set of instructions. First instruction, whatever the instruction present in the instruction register, the corresponding instruction line will be selected. Other instruction signals are 0. Here instruction decoder is used to select the instruction signal corresponding to the instruction available in the instruction register. And also here if any interrupts occur, then this particular input goes to encoder circuit. Okay. So, here conditional codes. If you take branch instruction, branch instructions are two types, okay, unconditional branch and conditional branch. In case of conditional branch, here conditional codes, nothing but after performing any operation, if output is 0, then 0 flag will be set to 1. If the output is negative, then sign flag or negative flag will be set to 1. Okay, if the output is having carry, then carry flag will be set to 1. Likewise, some conditional flags are there. Based on that condition, processor jumps to the specified location provided in the branch instruction. Okay, so likewise, based on the conditional code, whenever conditional branch occurs, then it issues the signal to the encoder. Now encoder generates the required control signal based on this instruction specified in the instruction register and timing signal provided by the control step counter and any external input or branch instruction based on the conditional code. Okay. Likewise, this encoder circuit will generate the control signals based on the information provided by all these inputs. Okay. Now, let us see how the control signals are generated in detail, or we can say let us see the circuit of this encoder block. In previous video, we have discussed about the branch instruction. Okay, see again I will tell you here, if you take main program, this is main program. Main program, suppose here branch instruction present. Okay, so here program counter is used to store the address of the instruction. Okay, or we can say address of the next instruction. Okay, so for example, program counter stores the address of the branch instruction. Okay, next to get the next instruction, program counter is incremented by 4, then stores in program counter. Okay, so likewise, if the execution of all the instructions are in sequence manner, program counter will be incremented by 4. Okay, if branch instruction occurs, okay, so branch instruction occur, suppose branch to the specified location, this is target address. Okay, at that address some other program may resides. Okay, then whenever branch instruction occurs, okay, branch to the specified location 2050. Okay, then this PC will be loaded with target address. Then jump to the specified target address 2050. Okay, then executes the respective program resides at 2050. Likewise, here PC will be updated with the target address instead of updating with the PC plus 4, that is address of the next instruction, address of the branch instruction. Okay, likewise here, so here if the execution of instructions are in sequence manner, PC will be updated by PC plus 4, PC plus 4, because instruction code size is 32-bit. Okay, to store 32-bit we require 4 memory locations. That's what every time PC address will be incremented by 4. Okay, PC is used to store the address of the next instruction. Okay, so if branch instruction specified, okay, then processor jump to the specified location. Now PC will be uploaded with the 2050. Now here before jumping to this subprogram, here this is the target address, or otherwise we can say offset address. Okay, I told you what is the offset address. Offset address nothing but target address minus the address of the next instruction of PC. Okay, so for example here branch offset address, if you mention offset address. Okay, so this is PC and next address is PC plus 4. Okay, so this if you add this PC plus 4, then you will get PC plus 4, then you will get the PC plus 4 to the offset address, then you will get the target address. the PC content and offset address are to be added before jump to the specified target address. Let us see for this operation. So, here we have discussed about after performing ALU operation, output will goes to Z register. Okay, before going to Z register, Z should be high. Okay, here ALU perform PC plus offset address in case of branch instruction. Okay, so PC plus offset address, then you will get a target address. Okay, now after performing this addition operation, output will go to PC register. Okay, that is target address. Okay, so before going to this PC, but after performing addition operation, the output will be transferred to the Z register by enabling Zn is equal to 1. Let us see how Zn equal to 1, that is the control signal issued by the control unit. Okay, let us see how that signal will be issued by the control unit. We have already seen the organization of hardwired control unit. So, let us see Zn. See, this is the control signal Zn. So, here let us see how Zn signal is generated. I told you in case of branch instruction. Okay, so branch address having PC having branch address. Okay, before going to jump to the specified address, okay, that PC content will be uploaded with the target address. Okay, so we need to add PC content with the offset value. Okay, so we need to add PC content with the offset address to get the target address. So, here T1 clock cycle is issued by the step counter. Okay, so here T1 Zn is always high during T1 clock cycle. Okay, now T4 signal is generated for branch instruction and T6 clock cycle is for addition instruction. Okay, in case of branch instruction, program counter address will be added to the offset address, and then that added output after performing addition operation, output will be stored into PC through Z register by setting Zn is equal to 1, because Z register is temporary register. Okay, used to store the output after performing any operation by the processor. Here this is the generation of this Zn control signal. Okay, see Zn equal to T1, here OR gate is used. Okay, so here AND gate is used. Okay, combination of T4 and branch signals are connected to the AND gate. Here the combination of T6 and add signals are connected to the AND gate. Okay, here either one of the input is 1, then output is equal to 1 of the OR gate circuit. Okay, so here Zn equal to T1, okay, T1 plus T6 into add, T6 into add and T4 into branch instruction. Okay, likewise Zn control signal is generated with the help of wiring diagram of all the logical elements. Okay, that's what this is known as hardwired control circuit used to generate Zn. Okay, this is you can say unconditional branch instruction. Next, let us see how end signal will be generated. Here after completion of any program, end signal is generated. After generating this end signal, control step counter will be reset, okay, with the help of reset signal. Okay, now here run signal is used to start the control step counter for another sequence of steps. Okay, last class we have seen to perform instruction we have seen 7 sequence of steps. Okay, so that requires 7 clock cycles. Okay, so likewise here if the 7 sequence of steps required, then T1, T2 up to T7 clock pulses will be issued by the clock generator. So now clock generator again reset with the help of this reset signal and end signal, and clock step counter will be start with the help of run control signal. Okay, let us see how this end signal will be generated with the help of hardwired control unit. Here generation of the end control signal. Okay, so the output is end control signal. Okay, this is the circuit of encoders we have seen in previous slide. Okay, so here branch instruction. I told you there are two types of branch instruction, unconditional branch and conditional branch. Unconditional, simply it will jump to the specified location, target location. In case of conditional branch, based on the condition, processor jump to the specified location for executing the another program. Here in case of branch, PC will be loaded with the branch target address. So how to generate the target address? Offset value which is mentioned in the instruction, that will be added to the PC content. Okay, then it generates the target address. So here addition is performed. That's what here addition instruction is used. Okay, this is unconditional branch. Here this is branch condition, branch instruction based on condition. Okay, branch if less than 0. Okay, less than 0 nothing but negative. Okay, negative nothing but n equal to 1. Okay, n equal to 1. If positive, then n equal to 0. N is nothing but it indicates the negative sign. Okay, so if n is equal to 1, that means branch less than 0, that means n equal to 1, then jump to the specified location and then end that program. Okay, otherwise, okay, this control signals will come into pictures. Okay, otherwise then stop the execution of program. Okay, likewise this end signal will be generated in case of conditional branch instruction. Before going to that, add instruction also performed. Okay, so to update the PC. Then here unconditional, this is we have already discussed. After completion of this unconditional branch instruction, end signal will be issued. Okay, so here T7 clock cycle is used for add signal, T5 is used for conditional branch. Next, in that condition, T5, T4 are used for conditional branch. Okay, if the condition is satisfied, then T5 signal will be activated, otherwise T4 will be enabled. T5 clock cycle used for branch instruction. This end control signal is generated based on all these input signals. Okay, so that's what here end signal equal to T7 into add signal plus T5. This is T5 into branch signal. Okay, next conditional branch depends on T5 into n, T5 into n, next plus T4 into n bar. Okay, so here, so T7 is for add instruction, T5 for unconditional branch, T4 and 5 for conditional branch instruction. Okay, so the combination of all this, either one of the input is 1, then output will be equal to 1. Okay, so likewise end signal will be generated based on the given inputs. Okay, the control signal is generated based on the wiring of all the logical elements. That's what this is named as hardwired control unit. Okay, in this topic, control signals are generated with the help of wiring of all the logic elements. That's what this is known as hardwired control unit. Likewise, all the control signals are generated according to the instruction specified in the instruction register. Let us summarize this topic. Control signals are used to coordinate the activities of the processor. Okay, so there are two ways to implement the generation of control signals. Okay, those are hardwired control and microprogrammed control. Okay, so in this topic we have concentrated on hardwired control. Later classes we will concentrate on microprogram control signals. Okay, so in this case we have seen how to generate the Z-in and end control signals with the help of logical functions, or we can say wiring of logic gates. Let us move on to the questionnaire slide. What is the function of control step counter, and what is the function of hardware control unit, and what are the conditional codes? If possible, all of you put all these answers to these questions in comment box. Thank you. We will meet in next video.